Every day, it feels like we're just swimming in this ocean of information, right?
Yeah.
Articles, studies, notes. It's a real task just figuring out what's actually important, especially with the really complex stuff, the nuanced topics, and this challenge. It gets even sharper when you look at advanced AI models, particularly when they're trying to tackle real-world tasks where, there isn't just one single right answer.
Yeah, it's a fascinating problem. I mean, AI has made incredible strides, definitely, in areas where you can verify the outcome, like math or coding, stuff where there's often a clear right or wrong.
Right.
But so many real-world jobs involve, well, subjective judgment and the traditional ways of training AI for this, like simple preference ranking. They run into issues. Often you get these opaque systems. It's hard to tell why the AI decided something was good.
Like a black box.
Kind of, and they can overfit. Maybe the AI learns that longer answers are always preferred, or it picks up on weird formatting things rather than the actual quality. Plus, doing this with human judges on a massive scale, it gets really expensive, really fast.
So that's the core challenge we're looking at. How do you teach AI to generate good content when good itself is so subjective, so hard to pin down? And the framework we're diving into today is called Rubrics as Rewards, or RAR for short. It's positioned as a way to tackle exactly this problem, to give AI clearer, more interpretable guidance in these tricky areas. So our mission today is to really unpack RAR. How does it work? What makes it effective? And what's the latest research actually showing about its performance?
Oh.
Okay, let's dig into this then. How does RAR actually take this idea of goodness and, well, make it something an AI can learn from?
Right. So at its core, RAR uses structured rubrics. Think of them like detailed checklists. It's a feedback mechanism for the AI. The idea is to break down what makes a response good into smaller pieces, smaller, tangible criteria that are, importantly, easy for humans to understand.
Okay, like a grading rubric you might see in school, but for AI.
Sort of, yeah. It's a really neat middle ground. It's more nuanced than just saying right or wrong, but it's also more structured than just a broad subjective preference, like I like this one better. So for each prompt the AI gets, there's a specific set of rubric items defined, and each item has a weight. And for each item, there's a simple binary check, a 0 or 1. Does the response meet this specific criterion, yes or no? Then the final reward the AI gets is basically a normalized sum of the scores for all those weighted criteria it met. Normalization is key there. It keeps the reward signal consistent, even if different prompts have, different numbers of rubric items or different weights.
Right, so it's not just a thumbs up or thumbs down. It's more like you did well on criteria A and C, but missed B, and those points add up, giving specific feedback.
Exactly. Specific, actionable feedback based on predefined qualities.
Now, you mentioned the reward is a sum, but the research actually looked at two different ways to calculate that reward. Right. Two ways to aggregate the scores from the rubric items.
That's right. And understanding the difference is pretty important. The first way is called explicit rubric aggregation. Here, each rubric item is checked independently. Did it meet the criterion, yes or no? Then you just sum up the weighted scores for the ones it passed.
So very direct, almost mechanical. Check the boxes, add the points.
Pretty much. Now, the second method is implicit rubric aggregation. This one's a bit different. It brings in another AI, an LLM-based judge model. This judge model gets the original prompt, the AI's response, and all the weighted rubric criteria.
Okay.
Instead of just adding scores, the judge model computes a single overall rating, usually like a Likert scale, say 1 to 10. And that rating is based on its holistic understanding of how well the response satisfies all the rubrics considered together.
Ah, I see. So explicit is like a strict checklist sum, while implicit lets another AI judge look at the checklist and the answer and then make a more nuanced overall judgment based on those criteria.
That's a good way to put it. The implicit method gives the judge model more interpretive freedom, you could say, based on the provided rubric structure.
That's really interesting, the idea of using AI to evaluate AI. But what about creating the rubrics themselves? You hinted they use LLMs like GPT-4o for that. Is it really AI teaching AI what good looks like by generating these evaluation checklists? That sounds potentially very powerful.
It is a key part of the process, yeah. Using capable LLMs as expert proxies to generate the initial draft of the rubrics. But crucially, this isn't just letting the AI run wild. The generation process is guided by 4 really important design principles. They need to be high quality.
Okay, what are those principles?
First, they have to be grounded in expert guidance. This means the rubrics aren't just made up, they're informed by reference answers. These references might come from actual human experts, or sometimes from even more powerful LLMs. They capture key facts, logic, style points.
Got it. Grounded. What's next?
Second is comprehensive coverage. The goal is for the rubrics to cover multiple aspects of quality. Not just factual accuracy, but also things like logical structure, how complete the answer is, the writing style, and importantly, they also include criteria for common pitfalls or mistakes to look out for and penalize.
Oh, so they define what not to do as well.
Usually you end up with somewhere between, say, 7 and 20 rubric items for a single question, including those pitfall items.
Makes sense. What's the third principle?
Third is semantic weighting. Not all criteria are equally important, right? So items get assigned weights or importance levels, like essential, important, maybe optional, and of course, pitfall reflects their priority.
Right. Reflects real-world priorities. And the last one.
Finally, self-contained evaluation. This is vital for practicality. Each rubric item should be evaluable on its own. The person or AI doing the checking shouldn't need external context or deep domain knowledge to decide if the criterion is met. Just the response and the rubric item. Makes it clear, actionable.
So grounded, comprehensive, weighted, and self-contained.
Exactly. And these principles were used to build some significant data sets mentioned in the research, like RAR Medical 20K and RAR Science 20K,
Right.
applying this method to specific domains.
Okay, so we have this sophisticated way to create and use rubrics and these two aggregation methods, explicit and implicit. The big question then for anyone listening is probably, okay, but does it actually work better? What did the experiments show?
That's the crucial part, of course, and the results were quite promising. They ran experiments using an algorithm called GRPO. It's a type of reinforcement learning suited for these kinds of reward signals. The base model being trained was Quen 2.57b, and they used GTF4 Mini as the judge model, particularly for that implicit aggregation.
And the data sets.
They tested it on benchmarks like HealthBench 1K, which is for medical questions, and GPQ at Diamond, which is more general science and reasoning. And the main takeaway, RAR implicit, where the AI judge used the rubric holistically, consistently, did better than the baseline. The baseline was simple like, where a judge just gave a 110 score without any rubrics. Just a gut feeling, basically.
How much better?
Significantly better. On HealthBench 1K, they saw up to a 28% relative improvement with RAR implicit compared to simple Likert.
28%. Wow. Especially in a medical context. That sounds like a big deal.
It is. And on GPQA, it was around a 13% relative improvement. It suggests that providing that rubric structure really helps the judge make better, more consistent evaluations, which then leads to better training. That 28% on HealthBench really points towards AI potentially giving medical info with, more accuracy and maybe even more nuance closer to what you'd want.
That's impressive.
Yeah.
So it beat the simple rating. How did it compare to other methods? Maybe something more sophisticated than just a basic score? And what about implicit versus explicit?
Good questions. RAR implicit also performed very well compared to another baseline called reference Likert. That's where the judge model compares the AI's response directly against a gold standard answer written by an expert.
Okay, so comparing against an ideal answer.
Right. And RAR implicit generally matched or sometimes even surpassed the performance of reference Likert. This is pretty significant because it suggests a well-designed rubric can guide the evaluation just as effectively as having a perfect answer to compare against.
And potentially be more transparent about why it's good.
That's a major advantage. The rubrics make the evaluation criteria explicit. You know it's being measured. And regarding implicit versus explicit aggregation, the implicit method generally came out on top.
So letting the AI judge interpret the whole rubric was better than just summing the weighted checks.
It seems so. It suggests that the LLM judge can do a better job of balancing the different criteria in context, perhaps more effectively than fixed, pre-assigned weights allow. It's a more nuanced aggregation. And overall, this rubric approach gives you more control and transparency, which helps reduce bias and overfitting compared to just comparing against a reference answer, which can still be a bit of a black box itself.
That transparency angle feels really important. It sounds like it's not just about squeezing out more performance, but building AI we can actually understand and maybe trust more. Which brings me to another point. I think the research touched on how RAR helps align the AI models better with what humans actually prefer.
Yeah.
What do they find there, especially regarding maybe smaller models and the role of that expert input you mentioned earlier?
Yeah, the alignment aspect is crucial. The research showed that using rubrics consistently improved the accuracy of the judge models themselves. This held true across different sizes of judge models, from smaller ones around 3 billion parameters up to much larger ones like 72 billion. Essentially, the rubrics help the judges get better at identifying and correctly rating the responses that humans would genuinely prefer.
So the rubrics act like guardrails for the judge AI.
In a way, yes. Structured guidance. And interestingly, the smaller judge models seem to benefit the most. Using rubrics help narrow the performance gap between these smaller judges and the much larger ones. It suggests rubrics can be a way to get more out of less massive models for evaluation tasks.
That could be really significant for making this kind of training more accessible.
It could be. And reinforcing that earlier point, the study really emphasized the value of expert guidance in creating the rubrics. Specifically, using those expert-written reference answers during rubric generation made a big difference. Rubrics developed with reference answers led to significantly more accurate evaluations compared to rubrics generated without them.
So human expertise feeding into the rubric design is still absolutely critical for getting the best results. It's not just AI evaluating AI in a vacuum.
Precisely. It highlights that synergy between human insight and AI capability. Human knowledge shapes the criteria that the AI then uses to learn and evaluate.
Okay, so let's try and wrap this up. It feels like the main takeaway from this deep dive is that Rubrics as Rewards, this RAR framework, it offers a really clear, structured way to train language models. Especially in those fuzzy, subjective areas without easy right-wrong answers, it brings transparency, which you talked about.
Transparency and interpretability.
Right. And the research shows it delivers strong performance, often better than simpler methods, and helps align the AI more closely with human judgment.
I think that covers it well. It's a promising step towards more reliable AI in complex domains.
It really seems like it.
And maybe a final thought for you, the listener, to consider. This exploration of RAR really shows something fundamental, I think. It shows how breaking down complexity, even the complexity of goodness in language, into smaller, human, understandable parts can lead to real breakthroughs, even with incredibly advanced AI. Think about this shift, moving away from these kind of opaque, trust me evaluations towards clearer, structured criteria like rubrics. How might that change not just how we train AI, but how we understand, interact with, and ultimately trust these increasingly capable systems? It points towards a future of AI that's hopefully more audible, more transparent, something to mull over.